All right, welcome back to second semester statistics on ramps. I'm really excited to be spending the second semester with you. Some of you, it's going to be your last semester here at Martin. So this will be a fun time. We're going to move into chapter 5. 5.1 is paired t-test, discusses paired t-tests, and that's different than the t-test that we discussed in chapter 4. Now thinking about chapter 4, when we did a paired t-test, those were like before and after. They were taking the sample, two samples from the same population. A two sample test that we're talking about today they are independent t-tests. And so what that is we're taking two samples from different populations. So let's fill these notes in for ourselves so we can kind of start taking a look at these paired t-tests. So a two sample independent t-test helps us evaluate the difference in means between two unrelated groups. So this is also called independent. So let's talk about examples. Now, one example is if I compared the difference in means or average heights of male and female basketball players. So notice that one population would be from male basketball players and the second population would be female basketball players, right? Another example is comparing GPAs from seniors and freshmen. So one population would be seniors and the other population would be freshmen. So let's see, the mean, here's one example, and then I want you to come up with your own example. Mean difference. So the mean difference in their grades in between freshman and senior GPAs. So we're looking to see if there is a difference in the means. So if I'm thinking about difference in means, my null hypothesis would always be that there's not a difference. So that would be that their means or their averages are equal, right? So the null hypothesis would be that the average from one group would be equal to the average from the other group. Remember, mu is mean. Or that their difference in means would equal 0. So either way, these two ways that I'm writing it here are acceptable ways to write the null hypothesis. Either that the averages are equal or that the difference in the averages equals 0. So that's always going to be my null hypothesis. So that is the population mean of one group equals the population mean of the other group. All right, so my alternative hypothesis then would be that if I wanted to reject the hypothesis, the alternative hypothesis would be that the mean for one group would not equal the mean for the second group. Therefore, their differences in means would not equal 0, right? So you can write this either way. We would be finding the same thing when we're conducting our t-test. So the population mean of one group does not equal the population mean of the other group. All right, so let's talk about assumptions here. Sometimes we can get a little bit mixed up with assumptions. And we need to make sure that our assumptions are met. That way, when we conduct our t-tests, that we're getting correct information. So one thing that we would think would not be true, but actually the groups do not need to be equal in size. And we'll see this in our example. We don't have an equal size. The samples must be independent. Distributions must be normal. And these are assumptions that we had to meet on our other t-tests as well. And then our observations must also be independent. All right, so let's look at our formula. Now, some of these vocabulary terms are very similar, like standard error. To find standard error in our other t-tests, we had to do standard deviation divided by the square root of n. Well, since we have two standard deviations and two sample sizes, our formula is going to be a little bit different. Therefore, that affects our t-statistic formula. So this is the difference in the means, right? And the difference in the hypothesized means. And so remember, when we're doing a t-test for paired samples, the difference in our hypothesized means, we always want it to equal 0. So I'm going to write this always equal to 0. I do want to add something else up here that I forgot to mention. When the two groups are not equal in size, that could affect us finding our degrees of freedom, right? Because our degrees of freedom are n minus 1. Well, which n do we take if we have two groups? We're going to take the smaller degrees of freedom. Take the degrees of freedom of the smaller sample. So just an FYI on that one. All right, so what do these values mean? This S1 and S2, that's the standard deviation. Of group 1 and 2. So these subsets here just signify which group it is. So if this is like group X, this is group Y, it's just naming the groups. And this is obviously your squared symbol. So when you put the standard deviation in here, you are going to square each of the standard deviations. All right, so therefore our n's down here, that's sample size. So think, if I'm talking through the formula, the standard error equals the square root of standard deviation of group 1 squared divided by the sample size of group 1 plus the standard deviation of group 2 squared divided by the sample size of group 2. So that's how we would write that formula. All right, so our test statistic formula here, again, we said this is always 0, right? Because our hypothesized difference in means, we want it to be 0. Always equals 0 there. And this x1 or x bar 1 and x bar 2, that's the sample mean for group 1 and 2. So this is the sample mean for group 1 minus the sample mean for group 2 subtracted minus your hypothesized difference, which we know is 0, divided by the standard error that we found here. So let's move on down and we'll interpret the results. So this is the last step of conducting our paired t-test. What does it mean when we reject the null hypothesis? Well, when we reject the null hypothesis, we're saying that there's significant evidence to suggest that the differences between the first group and the second group are different, right? So there is I'm just going to show it to you. That way you can write it down. So when we reject, we know, and I'll draw us our little picture here, right? It means that it's in our critical region here. So when your t-statistic is found in our critical region, we know that we're going to reject the null hypothesis, meaning that we have found a statistically significant difference in the means. Therefore, the difference is too great to have happened by chance. So we're pretty sure that there's a difference in the averages. Then our fail to reject our null hypothesis, this just means that we do not have enough evidence to say that there is not a difference in means. Does it mean that we're accepting it? No, it does not mean that we're accepting it. It just means that we don't have any evidence to prove it incorrect. So if we find our t statistic between our two critical values, then therefore we would fail to reject the null hypothesis. I know coming back after the break, you're like, okay, now I remember, right? All right, let's flip it to the back page and we'll do an example of this together. All right, so let's read this over, and I'm just going to circle my important words or numbers. A researcher at the university wants to determine if female college students sleep significantly longer than male college students do. They collect data on a random sample of 51 female students, and they find they sleep an average of 7.95 hours, the standard deviation of 1.8 per night, while 41 male college students sleep an average of 7 hours, a standard deviation of 3.06 hours per night. Conduct the appropriate test to determine if female college students sleep significantly more than male college students, assuming that the population variances are not equal. So here we want to say, what test are we going to conduct? We're going to conduct a paired t-test because they're both independent from one another, right? Our populations are independent. We're looking at female college students and male college students, right? So because they're not the same, they don't overlap, we're going to do a paired t-test. So let's write our null hypothesis. Our null hypothesis is that the averages would be equal, right? So that would mean that male and female college students sleep the same amount. On average. And then our null hypothesis or our alternative hypothesis is that their averages are not equal. So we would say that male and female college students do not sleep the same amount. All right, so does this study meet the required assumptions? So yes, it does. They collect its random samples. The numbers are where they should be. And so yes, we will say that we met assumptions. Significance level. Okay, remember our significance level is alpha, and alpha equals 0.05, just as a reminder, right? So let's name our variables. So we're going to get our values from up here in our word problem. So in one, let's say that our first number one, we'll say one is females and two is males, just because they're written that way in the paragraph. So in one is females, so we had 51 females. The average sleep time was 7.95. The standard deviation for females was 1.88. There were 41 males. Their average was 7, and the standard deviation was 3.06. So just looking at this, I can go, well, obviously the men or the males slept less than the females, but look at their variance, right? Their variance is a lot larger than the females. So the spread of their sleep times is larger. So just because the average is smaller doesn't mean that there is a significant difference, right? But that's what we're going to find out. All right, so our M1 minus M2, we remember, is 0, right? Our null hypothesis is that their difference is 0. Our degrees of freedom, we're using the n equals 40 because n equals 41, sorry, because that is the smaller of the two, 51 and 41. So we're going to use the smaller of the sample sizes, that's 41. So degrees of freedom is 41 minus 1, and that's going to be 40.